Hello everyone, today let's solve the problem number 424, longest repeating character replacement. So what the question states here, we are given a string s, you can clearly see here, we have been given a string s and an integer k, right? So we have been given a string s and integer k, we can change at most k characters in s. So accordingly with the k, the integer that they have given here, we can change at most k characters in s. Fine. To any other uppercase English letter. To any other uppercase English letters. We can change at most k characters and s to any other uppercase English letter. What we need to find then? We need to find the length of the longest substring that contains the same letter. So we need to find the length of the longest substring that contains the same letter. This is very important. We need to find the length of the longest substring. Return the length of the longest substring containing the same letter, right? You can get after performing the above operations, right? After performing these changes, whatever the changes that I have said, right? So that's what. Easy to understand, right? I hope the question is completely clear. Let's come to the example part here. So here you can observe we have been given k equals 2. Means we can change any letter twice, right? Here in this case, suppose here we have 4 letters, 2 distinct letters. We can change either a or we can either change b here. See, if we change b to a here, this one b to a, 2 times we can change, right? Here this one also will change to a. So this will be a and a. This is fine. Or we can just change a to b, right? A to b here. This will be b and b, right? So either we can do this one, or either we can get 4 times a, or we can get 4 times b. Both are valid, right? So we need to return the length here. In this case, both are having the length 4. So we need to return 4. So we can replace the 2 a's with 2 b's or vice versa. They have given in the explanation, right? Simple to understand. Let's go with the example 2 here, right? So here when I say example 2, just give me a second here. This one. So here we have single b here, this one b, between these 2 a's. So if we change this one k, we have been given k equals 1. We can change only one letter, right? So if we change b here, in this case, we get 4 a's as well here. In this case, 4 a's. Then we will be having BBA. So here in this case, longest the length of the longest substring here is this one, double A, right? So here in this case, so we need to return the length, that is nothing but 4. You can count 1, 2, 3, 4. 4. We have to return 4 in this case. Here they have clearly mentioned replace the 1A in the middle with B in the form of AA, double B, double BA. This one also we can do, or we can just go with, we can either change this one to A, or we can do one more thing here. So they have shown here, right? Here in this case, we can change this B to A, or we can do one thing here. In this case, we can change this A to B as well. So if we change that one here, this will become AA. So B, 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 A. And here again, the length of the longest substring, this one will be, this one we will consider. Again, this will be 4 as well. Either we can change this B to A or this A to B, right? You can do anything. Both will get the longest substring of the length 4 itself, right? So that's what. The substring double B has the longest repeating characters, which is 4. Why I did this one as, in the example they have showed this one. In the explanation they have showed this one instead of A, taking A, right? That's why I showed this one as well, right? So the substring double B has the longest repeating characters, which is 4. There may exist other ways to achieve this answer too. So as I've said, this one we can change this B to A as well. Same answer we will get, right? Length will be 4. So I hope the examples are clear as well. They have given wonderful examples to understand, right? So I hope the question is completely clear. Examples are clear as well, and what we need to do is completely clear as well. First, what we'll be doing, we will discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So here, let's discuss the approach step by step. The first thing that we need to notice here is we will be going with the sliding window approach, right? So we'll be going with the sliding window frequency count approach, or we can just consider this one sliding window approach, right? So I have considered the same example, the first example that they have given in the question, so that we have already discussed this one. Either we can change this B to A, this will become A, or we can change these two A's to B. As K, we have been given K equals 2, so we can just change the A to B's as well. So this one will be B. So length we need to return both. You can just consider one, the length is 4. Here you can clearly see 1, 2, 3, 4. Same goes with A, 1, 2, 3, 4. We have already discussed this one, right? Output is 4 in this case. So let's see the step-by-step execution here in this case. So we will start with the empty window. First, initially we'll start with the empty window, right? And expand by moving the right pointer. So we will be making use of the 2 pointers as we are going with the sliding window, right? Left and right pointer. Initially, L remains same, and we will move the right pointer. Once we will expand by moving the right pointer. We will move the right pointer step by step, right? So second step here is, let's move on with the second step. First step we know, this is simple to understand. Let's move on with the second step here. We will keep track of the most frequent character in the window. So this one is very important. We will keep track of the most frequent character in the window. This is the second step, right? So the third step, let's move on with the third step here. If the number of replacements needed means window size minus max frequencies, this exceeds K. This shouldn't exceed K, right? So if it exceeds K, what we have to do? We have to shrink the window from the left. We will be shrinking the window from left. This one we will see when we write the code clearly, right? So this one you will understand crystal clearly when we write in the form of code, or when we implement these steps in the form of code. Finally, we will update the maximum valid window size. We have to update the maximum valid window size itself. So finally, we will update the maximum valid window size. So let's consider this one for the example 1. So S equals AB, here K equals 2. We need to get the output 4 here, right? Let's see. Just give me a second here. What happened to this one? So yeah, here first this one, window A we are speaking. So here let's come to the first step. As we discussed, we will be starting with the empty window, expanding by moving the right pointer we have discussed, right? This one itself we will try to implement what we have discussed here. Window A, here in this case max frequency is 1, right? Max frequency is 1 in this case, and the length is also 1. Initially we are considering only A, right? So this is 1. Next we will consider AB together. These two we will consider. This is fine. So max frequency is 1 itself. Max frequency, both are having the frequency 1 here in this case. And length we are having 2. Length we are having 2. AB we are having, right? Max frequency we are having 1, and A is having the frequency 1, frequency count 1, and B is having the frequency count 1. So max frequency remains 1 itself, and length is 2. AB we have, right? So we can change B to A in this case, or A to B in this case. So maximum length is 2 here in this case. So let's come to the third step here. Max frequency is 2. In this case, either we can change here, we will be considering these 3 things together here now. A, B, A we will consider, right? So either we will be changing this one, B to A here in this case. Either we can change B to A or A to B here in this case, right? So here in this case, maximum frequency is 2. Maximum frequency is 2 and length is 3. Why length is 3 here in this case? ABA. We have length 3, right? So here in this case, window will consider all the 4. We'll consider all the 4 letters AB in this case, right? So we'll consider all the here B maximum frequency A maximum frequency is 2. A is of 2 and B is of 2. Here in this case, maximum frequency is 2. Length AB after converting this one, either A or B. This one, the length will be 4, right? So the length will be 4. Either you can consider this one A or B. So we will replace 2 A's here. We have considered You can replace 2 b's as well. It doesn't matter. So final result is 4, right? So this is also correct. We can just replace 2 b's as well, right? This is also correct and this is also correct. So the final answer we got here is 4, the length, right? So we got here is 4. So now we are completely familiar with the approach. So this is the approach that we are going with. Here we got the output 4, which is equivalent to the output that they have given for the example 1, right? So 4 equals 4 in this case. So the approach works absolutely correct in this case, right? So I hope the approach is completely clear. So we are familiar with the approach now. Let's discuss the this one, edge cases step by step. So let's discuss the edge cases step by step as we are familiar with the approach, right? So let's come to the first edge case here, minimum input. Just give me a second here, 1 second. So yeah, minimum input. Here in this case, we have only one character, right? So here k equals 0 they have given, output is 1 in this case. K equals 0 we shouldn't change anything. So output will be quite obviously 1 here in this case. This is for the edge case minimum input. Let's move on with the second edge case, all same characters. When I say all same characters, k we have been given 2. We already have the same letters here. We don't have to change anything. We can just give the output 4 in this case, right? So I hope this is clear. Let's move on with the third edge case here. All different characters. We have the different characters here, right? All the distinct characters here. A, B, C and D. So when we have been given k equals 2. We can change any 2 letters. In this case, let's change this one to A, right? So A, B becomes A and C also becomes A here in this case, right? So here A, D we have. So we will consider this triple A and the output will be 3. So because the length of the triple A is 3 here in this case. So the output will be 3 in this case. Let's move on with the final edge case or the fourth edge case here. No allowed changes. Here in this case, we have A, B and K we have been given 0. So the longest this one sequence here is this one. Without repeating, the longest sequence here is this one, A. So the longest substring that contains the same letter is here in this case is 2, right? The length you can clearly see. K we have been given 0, which we cannot make any changes in the S. So it will be 2 here. So the output will be 2 in this case, right? So these are the 4 edge cases that we need to consider here. So the first edge case that we went with here is minimum input. The second edge case that we went with here is all same characters. The third edge case that we went with here is all different characters. And the fourth edge case that we went with here is no allowed changes, right? Simple to understand these 4 edge cases. So the first thing here is, now we are familiar with the approach and we are familiar with the edge cases as well. It will be easier to write the code now. Let's try to articulate the same thing, the approach in the form of code. Let's start writing. So the first step here is, we have to go with the frequency array to store the character count. We have to store the character count somewhere, right? So we'll be making use of the frequency array here. So I can just write it in this way. Here, just make use of variable frequency here. So this will be new int of, I'll just make use of 26. As we are having 26 characters, I'll just be going with 26 here. This is fine, easy to understand, right? So I have already said that we'll be making use of the 2 pointers, and also we need to find the max values, right? Means max length. We need to find the maximum length of the characters. So we'll initialize the max length, this one to 0 initially. So let's go with 2 pointers initially. I'll just initialize left to 0, and also we need the max frequency as well. Max frequency, let me initialize this one to 0, and we need max length. Let me initialize max length to 0 as well. This is fine. So the next step here is, we have to expand the right pointer. We have to move the right pointer, or we have to expand the right pointer. For that, I'll just be making use of the simple for loop here. So here we have to traverse through the string s, right? So here int right, I'll just make use of the keyword right here. Right equals 0. Right less than length of the s here. This is fine. Length of the s, and let's increment the right here. This is fine. So within the for loop, what we need to do, we have to update the maximum frequency with the most frequent character count in the window. So in this case, we got 4, right? So after replacing the 2 a's or 2 b's, anything, We have discussed the same thing during the approach, right? So we have to update the maximum frequency with the most frequent character count, that is the window. So I'll just give here in this case, I'll just give here max frequency equals this one. Let me take it as math.max of, so let me copy this one, let me paste it over here. Max frequency, let's increment the frequency s dot char. I'll just make use of caret property. This one is fine. Caret right, we have to make use of. This is fine. So minus, so this one a, right? So this is fine. So we are just updating the max frequency with the most frequent character count in the window. That's what we have articulated the same thing in the form of code, right? So the next step after doing this, so if there are too many changes needed, then we have to shrink the window. We have already discussed this one in the approach, right? If there are too many changes that is needed, then we have to shrink the window, right? And we have to move the this one left pointer. We have already discussed this one in the approach, if you remember, right? I'll just write the simple while loop here. So I'll write minus left plus 1. So if there are too many changes that is required, right? This one is max frequency greater than k. Then what we'll do, if too many changes needed, then we have to shrink the window, right? So I'll just give here frequency of s dot char at this one. Let me give left here on this case as capital A. This is fine. Shrink means we are decrementing here, and we are moving the we have to move the left pointer, right? We have to move the left pointer ahead. So this is fine. So I hope this is clear. So the next step after this one here is we have to update the maximum substring length, right? So we have to update the maximum substring length every time. So I'll just consider, we have already considered the max length variable, right? So I'll just give here max length math.max of this one max length itself. First let me consider this one. Basically we will get max length by right minus left plus 1 by calculating right minus left plus 1. So I'll just give here right minus left plus 1. This is fine. So what we are doing here, we are just updating the max substring length every time, right? So the final step here is we have to return the maximum length that is found out of all the this one here in this step. Out of this one maximum substring length, we are updating the maximum substring length that is found at every step, right? So we will get the maximum length that is found, right? So that one we need to return finally, right? So I'll just give here return max length in this case. So this is it for the code. So let me format the code once and let me hit the run button. I hope this works. Let's see. This has to work. Let's see. Just give me a second here. Let me enlarge this one. Yeah, you can clearly see here the sample test cases are getting passed. Let me hit the submit button quickly. I hope this works for all the test cases. Let's see. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So the first thing that we need to observe here is the approach that we went with here is sliding window plus frequency count. We know this one, right? So we went with a sliding window plus frequency count. Nothing but we went with a sliding window. We have discussed this one. So the second thing here is what will be the overall time complexity here? So overall time complexity would be here big O of n. Why it is big O of n here? Because here in this case each character is processed at most twice. How it is processed at most twice? Once when expanding right pointer, if you remember, once when expanding and once when contracting. We are moving the left pointer, right? So once when expanding, nothing but we will move the right pointer ahead, and once when contracting means here in this case somewhere we have written this one, right? So we are moving the left pointer. Why we are moving the left pointer here in this case? So if there are too many changes that is needed, we need to shrink the window and we have to move the left pointer ahead, right? This one I'm speaking of for this case. So that's what I'm speaking here. That's what I'm saying here. So each character is processed at most twice, once when expanding, nothing but we are moving the right pointer, and once when contracting, that is nothing but we are moving the left pointer ahead, right? So that is why overall time complexity here is big of n. So what will be this overall space complexity here? Overall space complexity is big of 1. Why? Because we have the fixed size frequency array. You can clearly see here. We have the fixed size frequency array. Nothing but int of 26 here, right? So we have 26 characters. So that is the reason we are considering 26, the number 26 here. We have fixed size frequency array, nothing but int of 26 here. So overall space complexity would be big of 1, constant space, right? So the time complexity would be big of n, and the space complexity would be big of 1 for the code that we have written. So I hope this is clear, complexities are clear, and I hope whatever the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.